Hello, my name is Carlos Wong. I'm a senior principal software engineer with Thales. This presentation is on securing Amazon S3 buckets using the Thales Cipher Trust transparent encryption and employing a feature that makes use of access controls on dual endpoints. So let's start with Amazon bucket leaks, something that seems to happen quite often. As everyone knows, businesses have been moving to the cloud for computing storage resources, and with AWS buckets being the most widely used of the various cloud storage solutions. AWS S3 is used to store all kinds of data, including sensitive personal information and mission critical ones. So this makes the assets in S3 buckets attractive to hackers. For example, as you can see, here are three fairly recent events. The thing that's common among the three breaches that you see here is that all three had to do with misconfiguration or poorly configured buckets. Of course, there are other ways for exploits, but most configurations seems high on the S3 list. And a worst case scenario is having some misconfiguration that gives an attacker the opportunity to encrypt and potentially overwrite the original data. This potentially opens it up to ransomware attacks. I'll have more on ransomware later. So, so far as security goes, AWS uses a shared responsibility model where the responsibility for security is shared between AWS and the customer, with AWS mainly taking on the responsibilities of protecting its cloud infrastructure, while the customer ends up taking on the security of their data. AWS is by no means the only cloud provider that requires this sharing of duty model. As you can see on the slide here, Azure also splits the responsibility with the customer. It seems that regardless of the type of deployment, the customer, as usual, owns the responsibility for the security of its data. One thing, AWS does provide a number of security services available that its customers can use. However, as we all probably know, that securing the data in the cloud is not an easy task. AWS bucket or IAM policies, for example, can get pretty complicated and easily prone to mistakes. So that's one reason misconfiguration is a very common occurring problem and a leading cause of many breaches occurring on S3 buckets. So we ask ourselves, why do data leaks keep happening? First, basically the human errors. I would guess that policies supporting a large, complex cloud environment can get quite complicated and messy, and therefore one can expect things to be buggy. Second is the fact that bugs in softwares do happen and will probably continue to happen. And historically, insiders have always been a problem. For example, root users have way too much power to view or change anything he or she wants on a given system. So, and often than not, applications that interfaces with S3 often leave S3 required information in their configuration files, including AWS credentials. this makes it potential easy picking for a privileged user. And an example of an insider case is the one with the former AWS employee that happened to leverage her position in the AWS to identify servers with misconfigured firewalls and ended up getting a hold of AWS credentials. You may recall this as the Capital One breach that happened a few years back. Okay, so what can we do about all this? Well, here's some next steps. Well, one thing we can try to completely get rid of all human errors, but that seems to be going against human nature, I think. By nature, we are inherently error prone. Or, see, we can find all vulnerabilities before the bad guys find them and exploit them. But I think the bad news is that the bad guys will most likely find them first before you. Or we can have all our insiders become trustworthy, and then we can trust that they will never turn against you. But even if your admins are good, there's always a possibility that their privileged accounts can get compromised. Anyway, good luck with that. Good luck with that plan, that is. So, we believe that the best approach is to encrypt your data, and together with the ability to control your own keys. So basically, encrypting your sensitive information will help ensure that your data meets any safe harbor regulations. Safe harbor meaning you can avoid the need to report a breach if the data happen to be if the data is encrypted. So here are the necessary layers of protection that will help guarantee your data to be safe. One, you need definitely need strong encryption. You certainly need the fine-grained access controls. That is, you need to be able to choose who and what is allowed or denied access to your data. This also means controlling your privileged users and also control of the applications that are being run on your system. Third, you need to have some form of audit logging. This is to provide detailed records to give you insight into who and what and when your data is being accessed. And finally, you need a centralized management system. This is essential to manage your encryption keys and your access control policies. So this essentially takes us to the Thales Cipher Trust Transparent Encryption. As you can see, it has available all the layers of protection that we just mentioned in the previous slide. One, it provides encryption using a strong 128 or 256-bit AES. It supports CBC CS1 encryption mode for regular files and S3 objects, and also has an XTS mode for storage array types. Second, Cipher Trust Transparent Encryption has granular access controls. The security administrator can frame a combination of client host policies to allow or deny actions like reading, writing, deletions, and so forth. And together with the ability to control who, what, and when is accessing your sensitive data at any given time. You also have the ability to restrict root access to your sensitive data. You can give an sysadmin only the minimum necessary permissions in order for the sysadmin to say perform his or her job, such as being able to only read the data without having the ability to decrypt it and have it viewable. So basically, you can have them do their task without actually giving them the ability to actually see the actual data. In addition, you can also whitelist a set of applications that are permitted access. Third, it has audit logging, right? Cipher Trust Transparent Encryption has audit logging to provide a trail of events to give insight into activities and events that are occurring, and that sort of helps you stop threats, potentially help stop threats quicker. And finally, we have there's a Cipher Trust Transparent Encryption works in connection with the Cipher Trust Manager, which is a centralized key management system. It helps manage all your encryption keys and access control policies to help secure the protection of all your data. So basically, just one more word on Cipher Trust Transparent Encryption is that it provides you the ability to bring your own encryption and security to the cloud. So for cloud security specifically, protecting S3 buckets and their objects, we have the Cipher Trust Transparent Encryption for Amazon S3. Cipher Trust Transparent Encryption also, I also refer to it here. I will be referring to it here as CTE, using its acronym. Offers support for securing S3 buckets. Once again, the 4 layers of protection we previously mentioned are all available for securing your S3 buckets. Note that encryption featured here is the encryption featured in the Cipher Trust Transparent Encryption is independent client-side encryption, not tied into the AWS S3 server-side encryption. Both encryption and access controls are transparent to the application, and it also does not require any changes to the way the S3 administrative procedures. And this added protection by CTE essentially remains in effect against S3 bucket unauthorized accesses, even as the bucket becomes misconfigured. The access control policies, for example, continue to be enforced and prevent unauthorized accesses. And even if the data is breached, note that it remains encrypted, and so it's essentially basically unreadable to anyone. So CT for Amazon S3, the CT support for Amazon S3 is an installation option that we call the Cloud Object Storage. we will note that we will refer to it here as CTE COS, or sometimes simply COS, COS. It's basically contains a proxy component performing TLS interception of S3 requests from the client applications. The applications are required to redirect the request to the proxy on the local host and a specific port. The proxy used by CTE COS is the Squid proxy. Squid proxy is a popular open source proxy server. CTE COS basically deploys one as a forward proxy only. And in addition, it has been customized and hardened. Some examples of the hardening include the following. One, it only accepts local connections. Anything coming from the outside, the local host is rejected. Only takes TLS 1.2 and 1.3, which are the current standards. It also employs an OpenSSL library that itself has been hardened via compile time options. In addition, the proxy has available its own private CTE guard point to basically secure its sensitive data such as key files and credentials. So this secure location is only accessible to root, the proxy, and CTE administrative tools. It's intended only for proxy-related usages. Oh, by the way, basically, now that we mentioned guard point, basically a guard point is a file system directory device, or in this case, an S3 bucket that CTE protects with access controls and encryption. Guard points, normally guard points are managed per host in the Cipher Trust key manager. However, the one difference about this private custom version is that it's automatically initialized and activated locally. No intervention from the Cipher Trust key manager. Okay, so the proxy basically uses ECAP to provide the interface between the proxy and our CTE COS S3 adaptation module that filters the S3 request and initiates access controls and the encryption. All these pieces are integrated as libraries within the proxy. S3 buckets are also secured via guard points that are applied from the centralized key managers. Basically, buckets are addressed in the same manner as S3 does, as seen in this URI example shown in the slide. And finally, the dual endpoint feature that we sort of made mention at the very beginning. Which is the name for that is called the end-to-end access controls, is the CTE cloud storage option with some additional setup steps. So let's take a look at this end-to-end access control. The idea behind end-to-end access control feature is to basically leverage two existing available points of control, one on the local CT host and the other on the remote AWS server end. So it employs these two means of control simultaneously. They work in tandem. Its function is to limit S3 access requests to only those from the host running CTE with this end-to-end option appropriately configured and activated. So here's a diagram that hopefully gives a clearer view of the effects when attempting to access S3 buckets with the end-to-end feature in action. So essentially, we have two wide open public buckets for the purpose of this example. The one difference that the green one on the left is secured using the end-to-end access control feature. The yellow open bucket is accessed successfully by all the clients attempting it. Obviously, it's wide open. However, the green one on the left, no one has been able to access it except the host on the left. The reason access for that host succeeds is because it is running the Cipher Trust transparent encryption with the end-to-end access control feature configured and enabled. The green bucket is pretty much locked down, and all requests must go through the Cipher Trust transparent encryption. The red arrow from the CTE host could be viewed as a request that tried to bypass the end-to-end controls, or it could be just the result of a regular access control request that was denied. So hope this gives a little more idea of what the end-to-end access control affects. So how to set up the end-to-end access controls? There are two steps, right? One is to set up this IAM role stuff on the AWS end. So to enable end-to-end, one needs to, like I mentioned, this COS-specific IAM role to be set up. So first, you need to set up a role policy that defines access to a bucket. I'll show some JSON example after this. Then create the IAM role and assign it the role policy. And then finally, you need to create the IAM user that will have that will be able to assume the role, IAM role. And basically that's it. It's a pretty standard AWS IAM configuration, at least from a high level. So here's the sample policy. It's just very simple. As previously we mentioned, misconfigurations. Some of the issues could be, the fact that these IAM policies could be complicated. So here's a really simple one. It's just simply wide open. The reason we can leave it wide open is because, again, with end-to-end feature, access will mainly be controlled essentially on the client end. So you got now that you have the AWS setup done. Now let's see. Now we go through the configuration on the local host side. First thing you need is to register the COS IAM user that you just created on the AWS into the CTE COS environment setup. We have CTE administrative tools available to help you do that. You need the stuff that you need is basically IAM users AWS credentials. That is the key ID and the secret key. This will be used for authentication of the user in the S3 request and allow it to assume the COS IAM role. You also need to include the Amazon resource names for the COS role and the COS user. So with that, now we can go and basically secure the bucket. For security reasons, it requires the IAM user credentials to both secure and to unsecure the bucket. This is again done with the CTE administrative tool. So under the covers, this causes CTE COS to trigger an AWS bucket policy on the targeted bucket, and it restricts access only to the IAM role. So any S3 request not matching the assumed role is effectively denied. So that leaves the role as the only allowed pathway to access a bucket protected with this end-to-end access control feature. So essentially with end-to-end, the access controls to the bucket are basically, you can view as basically offloaded to the client host. The bucket is locked down, preventing access from other external paths. No one can access it through any path outside of CTE. In fact, not even through CTE, unless it is by this assumed COS IAM role. The local access controls take effect when the guard point is enabled for the bucket, a step that is done via the centralized Cipher Trust Key Manager. These access controls are based on control points using local identities and local applications. Examples of what can be used for local enforcement include using local user login identities and the location path and a signature of the application that's accessing the bucket. One thing to point out is that additional benefit from this end-to-end access control feature is that it provides an extra level of protections that we get by having and employing the access controls locally and together with the AWS IAM-based protection. An example could be a situation where the AWS credentials are stolen. Perhaps real-life example could be from something like the Capital One breach, where the perpetrator was able to obtain such credentials. So in such cases, I would go as far as to say that if the S3 buckets were secured with CTE end-to-end access controls, such a breach would likely not have been possible. First off, the attacker would have had to access the buckets only from authorized hosts running CTE end-to-end. So in addition, an attacker had to also know where those hosts are and then be able to log in and run with the appropriate local identities. And then there's the additional security restrictions CTE policy provide come into play. So I think plain and simple, just getting a hold of AWS credentials are not enough in this case. Also, I'll point out again that even if the end-to-end policy was disabled and access can be made from other external locations, just remember that the data is still encrypted. So you need to have CTE you need to be able to access the data to CTE. So let's take a look at a bit more details CTE side of the end-to-end access controls. The proxy is pre-configured with this adaptation meta directive, a squid thing. to pass into CTE COS adaptation service the client's connection port number. These connections are local, so we are able to identify who's making the S3 request based on the port. If the port number is not passed in, say configuration was removed on purpose or accidental, then by default, all requests are simply denied. I want to point out that CTE access controls are performed securely down in kernel space by the CTE kernel module. It has already been doing that for file system and now has been extended to support S3 buckets. If the local access control check passes, then the request continues its way to S3, where then it is AWS turn to perform the end-to-end access check. So the last bullet item just basically lists the bucket or object operations that are triggers the access check. So basically, we are armed with encryption and this end-to-end access control. How can these enhanced features help me against threats? Let's look at the S3 and ransomware. AWS configuration can be difficult, and misconfiguration is a leading cause of leakage and potential attacks, as we mentioned. Poorly configured bucket permissions, allowing someone to be able to copy and delete objects, can allow a attacker to replace the data with an encrypted version, which is basically ransomware. Also, S3 buckets are global resources, meaning that they can potentially be accessible from anywhere. An attacker does not need to gain access to the system, as it normally happens with most ransomware. And then there's always the insider threats. Then there's threats coming from the inside, because these privileged accounts are actually prime targets for attackers. In fact, I recall some recent news regarding ransomware groups actually attempting to recruit help from the inside. Anyway, AWS does provide a handful of security features and tools to use in securing S3 buckets, so versioning, object locking, and so on. But remember that AWS provides these tools, but again, it's up to you to use it correctly and to secure your data. So how can CTE COS and end-to-end access control help stop ransomware? Well, start by effectively locking down the bucket and limit the potential attack path that can originate from, except through the CTE COS with the end-to-end feature enable. This is effective even if the bucket guard point protection is disabled. Another thing is, as we mentioned, fine-grained access control. So one can define a combination of policy control points that, you, for example, can restrict access to only authorized users and restrict operations to deny the ability to, for example, encrypt, or perhaps access only to a whitelist set of trusted applications, which can block untrusted ransomware binaries from doing their thing in the first place, and so forth. And again, like to mention again, don't forget that there's still that last line of defense. The data is still encrypted, which makes it worthless. Okay, we're nearing the end. So some final thoughts. Once again, if your S3 bucket is poorly configured, your data can potentially leak out even if it's encrypted with AWS server-side encryption. On the other hand, with Cipher Trust transparent encryption, your data remains encrypted if your bucket is misconfigured and leaks out. In addition, the enhanced protection of the end-to-end access control brings an additional level of protection against potential ransomware attacks. Essentially, the Cipher Trust Transparent Encryption and Cipher Trust Security Manager that we've mentioned here are part of the Thales Cipher Trust Security Platform. And lastly, as always, the last line of defense in securing your data is to have it encrypted at rest. If your data is breached, it's worthless and there's no regulatory fines. So basically, bring your own encryption to the cloud, plus manage and take control of your keys, and increase the security to your sensitive S3 data with the enhanced protection that that this end-to-end access control feature brings. So basically, in the end, just avoid having your businesses be part of the next ransomware news headline. And with that, done. Thank you.